Good day. This is entitled Reaction Mechanism Analogy, and this is useful when we start moving on to our next PowerPoint, which is our reaction mechanisms and figuring out rate determining steps. But we want to think about something that's different from looking at a bunch of little chemical reactions. And we're going to consider a process you may be able to relate to, and that is dishwashing, and we're not using the dishwasher here. So we look at the steps, and we're going to analyze the steps. Step one is collecting the dishes. Bringing them to the kitchen, put them by the sink. That's a fast step. Washing the dishes, along with rinsing, is going to take quite a while. Drying the dishes will be quick. Putting away the dishes will be fast. And we're thinking about, like, after a nice big turkey dinner, when you have all kinds of family and or friends around for a meal, after, if the dishes have been done manually, you have all kinds of people who can collect the dishes. You have all kinds of people who can dry the dishes, put away the dishes. But typically you're just going to have one person washing the dishes. And what this means is when we look at these steps, these are sub-steps that overall add up to successful dishwashing. Some of the sub-steps we've said are fast, but one will be the slowest. And the slowest one is the rate determining step. If we get more people to gather the dishes, that doesn't make the overall process faster. It's still going to get snarled up by the washing of the dishes taking a long time. If we get more people with drying towels, that's not going to speed up because the dishes, cutlery, plates, all that are going to just gradually trickle out from the washing of the dishes. So the only way to speed up the process of dishwashing is to add some more sinks and dishwashing people. And what that's going to apply to chemistry is the only way to speed up a chemical reaction is to speed up the rate determining step. So in this case, our rate determining step is the washing step, and that's the only way to make it faster. And that's what it's talking about. And for some reason, this is written down twice because I cut and paste in a strange way. Speeding up any other step does not increase the rate of reaction. So remember this analogy when you're looking at reaction mechanisms and being asked to determine whether something affected or sped up the reaction rate or whether it had no effect on speeding up the reaction rate. That's it for the analogy.